Understand that using chance to select our sample is an essential principle of statistical sampling. We don't want to use personal choice. We understand that leads to bias, so we want to use chance. Any sample that is chosen using chance, we're going to call a probability sample. So a probability sample is a sample that's chosen by chance. We must know what samples are possible and what chance or probability each possible sample has. An SRS, an SRS is an example of a probability sample. But as the name implies, it is a simple sample. It is a simple strategy that we would use. A more complex probability sample might be one including a stratified random sample. The idea behind a stratified random sample is first we divide our population into groups of similar individuals that we call strata, and then we choose a separate SRS within each stratum, and we're going to combine these SRSs to form our full sample. For example, let's say we're trying to determine whether or not our high school should offer late buses after school, and we don't have the resources to ask every single student in the school, but we are able to come up with a sample and ask them that particular question. Well, in a simple random sample, in an SRS, what we would do is put everyone's names in a hat and maybe select out 20 names at random. Now, like we said, that's a pretty simple process. However, some of the drawbacks might include the fact that when we take our sample, we might be leaving out a particular group. We might be leaving out the freshmen. So there might be some issues with that. If I were to take a stratified random sample, what I would do would be to divide the school's population up into 4 groups: freshmen, sophomores, juniors, and seniors. They're all similar because they're all within the same grade level. And if I take an SRS of 5 individuals from each group, then combine those SRSs to get my 20 students, we have our stratified random sample. Notice that we would get a representation of all 4 grades in that sample, which might not happen in an SRS. When you're doing a stratified random sample, generally you're going to want your proportion of your samples from each group to be the same as the population's proportions. For example, when you divide your population up, let's say that 10% of the population might be faculty members and 90% might be students, you're going to want to make sure that 10% of your sample are faculty members and 90% are students. So it doesn't have to be an even divide. You could divide it proportionally according to what's in your population. A good example of a stratified random sample can be found in example 5.5 in your textbook. Who wrote that song? Now, understand that a stratified random sample is more complicated than a simple random sample. And when we get to our inference procedures later on in the book, when we talk about tests of significance and confidence intervals, we're going to actually be using simple random samples to help us understand those particular processes. However, even though we might get a better result from a stratified random sample, the inference procedure is a lot more complicated. So we're going to talk a lot about SRSs in this course. I mean, a stratified random sample is a good design, but it is a little bit more complicated, and the way we would use it later on is more complicated. Another more complex design might be what's called a multi-stage sampling design. As the name implies, in a multi-stage sampling design, what we're going to do is have multiple stages to our sample design. Instead of just maybe instead of one SRS, or taking a stratified sample from groups and just doing one stage and combining them, there must be multiple stages. Again, that's a little bit more complex, and it is beyond the scope of this course. But when we look at presidential elections and what they're trying to do to try to predict, they use multi-stage sampling to make sure that they hit some representative parts of our population to give them the best chance of predicting the possible outcome. Okay. Now, let's move on. We understand that random selection helps us eliminate bias when we're choosing a sample from our population. But we need to understand that when our population consists of human beings, if we want to get accurate information from our sample, we need much more than a good sample design. So we have some things we need to be careful of. The first thing we need to be careful of is what's called undercoverage. Okay, I was just interrupted, so I think I know where I left off, but bear with me. So one of the cautions we have to be careful of is undercoverage. Undercoverage occurs when some groups in our population are left out of the process of choosing the sample. For example, let's say that you're taking a survey of the school, but there's half of the junior classes out on a field trip. Well, when you choose your sample, you're leaving them out. And maybe there's something important about those students that are more likely to respond one way or the other. And you don't want to leave those students out. So that's an example of undercoverage. You want to make sure that you include as many people in that process of choosing your sample as are in the population. A second thing you need to be careful of is what's called non-response. Non-response occurs when an individual chosen for the sample can't be contacted or does not cooperate. For example, on telephone surveys, the person that you're trying to contact, either you can't reach them or they hang up on you. Now, there are ways and statistics for dealing with non-response as part of your sampling process. For now, we're just going to say that we're going to try to avoid non-response by doing everything we can to make sure that the people that we contact are cooperative or we get an answer from them. Take a moment and read example 5.6 in your book. They talk about how undercoverage relates to the U.S. Census. Okay, a couple of other things we need to be careful of. The first one is response bias. This is when the behavior of the respondent or the interviewer, we say it causes response bias in our sample results. And we'll look at an example in a moment. Another thing to be careful of is the wording of questions. The wording of the questions can be an influence on the answers that are given in a sample survey. The way in which those questions are worded might tend to bias the results that you're trying to get. Our goal, again, is to get an unbiased response, so we try to strive for questions that are worded fairly. Take a moment and look at examples 5.7 and 5.8 in your textbook for examples of response bias and the wording of questions. Now, finally, what I want you to be aware of, and this is going to kind of lead into chapter 6 when we get there, is that when we take our results from a sample, it's very unlikely that we're going to get the same exact results as from the entire population. If you want to know what % of high school students in our school are in favor of getting a late bus, and you take a random sample of 20 students, it's unlikely that the sample result that we get from those 20 students is exactly the same as the entire population. And as a matter of fact, if we take another sample of 20 students, we're probably going to get a different answer. But we understand that, okay, we're probably going to be close. Well, because we use chance to come up with our sample, the results that we're going to get must follow the rules of chance, that is, the rules of probability. And we'll talk a lot more about the idea of probability when we get to chapter 6. But the big idea I want you to get is that right now, if we have larger random samples, that will give us more accurate results than smaller samples. It makes intuitive sense, and we'll give a more complete understanding of why later on. This concludes section 5.1. Our next lesson on section 5.2, we'll start looking at experiment design.